Okay, so the question says L1 and L2 are two given lines, and we have another third line L, which is in the plane containing L1 and L2, and also it is going to pass through the point of intersection of L1 and L2, and L bisects the acute angle between L1 and L2. Okay, so these are the properties that they have given here, and using this one, we have to find out the unknowns alpha, gamma, L, and M. Then we are going to get your line equation, and of course, using that one, we can find out which of the options are going to be correct. Okay, so now if you actually see this L1, okay, so this L1 is going to be parallel to the vector M1 bar, which is going to be your denominator. So which is going to be simply I cap minus J cap plus 3K cap, that we can directly say. And similarly, your L2 is going to be parallel to another vector, let's say M2 bar. So that one is going to come as minus 3I cap minus J cap plus K cap, right? So these are the two vectors that we have here. So now we need to take the acute angle bisector of L1 and L2. So how we are going to get this one? So here we have line L1, let's say, and here we have line L2. So these are the line L1 and L2 that we have here. And for line L1, we are going to have a parallel vector M1 bar. And for line L2, we have another parallel vector, that is M2 bar. Okay. So now what they are saying, the line L, which we are trying to find out, is going to be the angle bisector. This is going to be along the acute angle bisector. So this one is going to be your line L. And similarly, I'm going to consider the acute angle bisectors of this M1 bar and M2 bar also. Acute angle bisector of this M1 bar and M2 bar also. Now, one simple thing that you can directly tell here. So the line L is actually going to be parallel to this acute angle bisector. But we know acute angle bisector of any two vectors is given as the summation of the unit vectors. So that means this acute angle bisector is going to be simply M1 cap plus M2 cap. So that means your line L is going to be parallel to M1 cap plus M2 cap. Okay, so that is what we are going to get. Okay, so that means your line L is going to be parallel to the M bar vector, M1 bar vector. We have it as the M bar vector that we have it as I cap minus J cap plus 3K cap, right? But we have to take the unit vector, so we have to divide it by the magnitude. So that is going to come as root 11 plus M2 bar is going to be minus 3I cap minus J cap and plus K cap upon this one is going to be root 11. Okay, so that means your line L is actually going to be parallel to, when you add this one, so we are going to get minus 2I cap minus 2J cap plus 4K cap upon root 11. So that means you can directly tell L is going to be parallel to the vector having drs as minus 2, and 4. But, okay, so this is one property that we already got, but they have already given the line equation. So what is the line equation L? So they have already given the line equation L as x minus alpha upon L is equal to y minus 1 upon m is equal to z minus gamma upon minus 2. So that means we already know L has to be parallel to L comma m comma minus 2 also. L has to be parallel to L comma m comma minus 2 also. From these two relations, what can we write? So let's say this is first one and this is the second one. So your L is going to be parallel to minus 2, 4, and L is also going to be parallel to L, m, and minus 2. So what this is actually going to tell you, the ratio is going to be same, right? So L upon minus 2 is going to be equal to m upon minus 2 is going to be equal to minus 2 upon 4. By comparison, we are going to get directly L going to be equal to 1 and m is going to be equal to also 1. So that is what we are going to get, L equal to 1 and m equal to 1, right? So then next thing that they have given, they said the L is going to pass through the point of intersection of the two given lines. So what are the lines? The lines are given as x minus 1 upon 1 is equal to y upon minus 1 is equal to z minus 1 upon 3. And second line equation is given as x minus 1 upon minus 3 is equal to y upon minus 1 is equal to z minus 1 upon 1, right? And their point of intersection, if you directly observe this, their point of intersection is nothing but 1, 0, 1. and they said the line L is actually going to satisfy this point because it is passing through the point of intersection of this. So that is means what, x minus alpha upon L is equal to y minus 1 upon n is equal to z minus gamma upon minus 2 is actually satisfied by this point. So if you substitute this, so we are going to get another relation. So what is that relation that we'll be getting here? If you substitute, we will be getting, so 1 minus alpha upon L, L is going to be equal to 1, and 0 minus 1 upon m, that is equal to 1, and that is equal to 1 minus gamma upon minus 2 that we are going to get, right? So we have put this point in this one and we got ultimately this one. That's it, right? So now from here, if you solve, we are going to get alpha equal to 2 and gamma is equal to minus 1. So these are the 4 values that we are going to get, and using this one we can find out what will be the answer. So let's go back and see what we are going to get as the answers now. So we have L equal to 1, M equal to 1, alpha equal to 2 and gamma equal to minus 1. So that is, we got L equal to 1, M equal to 1, alpha equal to 2 and gamma equal to minus 1. So now using these 4, we have to find out which options are going to be the correct answers for this. So I think that is a pretty direct one now, right?